Hey guys, welcome back to the YouTube channel Learn in DSA. So today we are going to solve LeetCode problem 2966. Divide array into arrays with max difference. So here what we are provided is you are given an integer array nums of size n, where n is a multiple of 3 and a positive integer k. We have to divide the array nums into n by 3 arrays of size 3 satisfying the following conditions. The difference between any two elements in an array in one array is less than or equal to k. Return a 2D array containing the arrays. If it is impossible to satisfy the condition, return an empty array. So if we cannot divide it into triplet of arrays, then we can return an empty array, and if there are multiple answers, return any of them. So basically if we look at the first example, then here we are provided in nums 1 3 4 8 7 9 3 5 1, where k is 2. So basically the difference between any two elements in each array must be less than or equals to 2 here. Okay, so we can see here in the output we are getting 1 1 3. So 3 minus 1 is 2, 3 minus 1 again is 2, 3 4 5 and 1 minus 1 is 0, so basically lesser than 2, and 4 minus 3 is 1, so lesser than 2, 5 minus 4 is 3, so lesser than 2, and 5 minus 3 is 2, so equals to 2, so satisfies the condition. 8 minus 7 is 1, 9 minus 8 is again 1, and 9 minus 7 is 2, so it satisfies the condition, and hence it is coming in output. And in output we need to provide the triplet of arrays. So basically how to calculate this triplet of array, we can so looking into the second example, here we can see nums equals 2 4 2 2 5 2 and k equals 2 is provided. So basically if we divide it into the like such parts, then it can be 2 2 2 2, okay, and 2 4 5. So basically if we subtract 5 from 2 here, then we will be getting 3, and k should be like that 3 should be lesser than equals to k, but here already k is 2, so it is not valid. Again if we divide into another thing like 2 2 4 and 2 2 5, then again 2 and 5 are coming together, so it is not possible in this. So here we are returning the output as empty. Okay, so let's look at the third example. So here what we are provided, nums equals 4 2 9 8 2 12 7. So in this also we are getting like this, here k is equals to 14. So if we subtract 12 from 2, then we get 10. Similarly, like here if we subtract 12 from 11, then we get 1, 12 from 2, then we get 10. So basically it satisfies the condition of k. So what we, if we look at these examples, then we can go to a pattern like first we are arranging the array. If we arrange the array in a sorted order, then what we can say, we can easily take the 3 triplets. Like if the array is already sorted, then we can take the first 3, then we can take the second 3, then we can take the third 3, and if in each in each triplet of 3 numbers, we can directly subtract the highest number to the lowest number to get, if it is lesser than equals to k, then only that triplet is valid. So, and if it is not, then we will be returning an empty array. So I think it can work. So if we look at the time constants as well, then here n equals nums dot length. So basically n is the size of the array, and n is a multiple of 3, and so on. K is less than equals to 10 to the power 5. So basically to handle this much complexity, sorting can work fine, because sorting algorithm generally takes, if we take the short nums dot begin comma nums dot end, then also it will be taking a time complexity of big O of NlogN, so it will work good. So let's move on to the coding part of this question. So what we will be doing here is, we will be initially like we are provided vector int ampersand nums int k. So basically we are provided a vector like an array of nums, and what we need to return in the output is a 2D vector which contain an array, like which is an array and contains triplets of array, like the arrays in triplet formats. So basically initially what we can say that we can take the size of the array n equals nums dot size. So basically that will be like that will be calculated like this. Here I am taking my language as C++. You can choose your desired language with this logic only, and you can also go on for other logics as well. So basically then we I already told that we need to sort it first. So basically we will be sorting it using the C++ library like the sort function, and this sort function is basically taking big O of NlogN time complexity. So it is good to go. So basically what we need to declare is like what we need in the output, a 2D vector, like 2D array. So vector int, we can declare it like this, and our output could be like result or answer or ARR if we want. Then we can like easily take that we need to calculate the loop. So basically what we are doing after sorting, we are taking three elements to compare. So basically we need to run a loop which is going for the like from I equals 0, I equals 3, then I equals 6, then I equals 9. So basically we are considering three elements at once. So for that we will be taking for I equals 0, I is less than n, I plus equals 3. Okay, so in each step 3 will be incremented. So what we told, if the I plus 2th element, like if let me give you an example. If we take the same example like this, if we take the same example like this one, so basically if we sort it, then what will happen? 1 1 3 4, okay, one more 3 is here, 3 3 4 5, we can see here 7 8 9. Okay, so if we compare, like we take these three elements first, like this first three elements 1 1 3. So what we can see here, this is at position 0, or if yes, we are starting from 0. This is at position 1, this is at position 2, this is at position 3, this is at 4, this is at 5, this is at 6 7 8. Okay, so basically if we compare these three elements, like this 3 1 1, then we can see here this 3 is at position 2, and whereas this 1 is at position 0. So 3 is basically greater than 1 because we have already sorted it. So if we subtract the higher position element to the lower position element, and if that subtraction is lesser than equals to k, lesser than equals to k, so we can conclude that it contains a triplet. Okay, and if it does not, then we need to return an empty array. Okay, so for that what we need to do, if for that comparison, nums I plus 2 minus nums I is greater than k, then what we will be doing, we will be returning, like if the subtraction is greater than k, then we will be returning an empty array. Okay, and if this subtraction is lesser than k or equal to k, then we will be pushing that value, like those triplets, to our output, our result output array, result 2D output array. Okay, so it will be like result dot push underscore back. We will be pushing that value to like these values, nums I plus 1 and nums I plus 2. So nums I comma nums I plus 1 comma nums I plus 2. So basically this thing should be, we are pushing that, na? So basically it will be like this. And to return the result array. Okay, so let's run this and check if it works. Here we can see, yeah, here we have not defined int I as integer. Okay, so let's run it again. Yeah, so now it's accepted. So if we look at the cases, then we can see here it is working fine in case 1, case 2 and case 3 all. um, it is, the output is coming perfect. So if we submit this, let's see if it works perfectly or not for all the test cases. So yeah, it is working perfectly. And let's look at the time and space complexity. So here what we can see, like this short function is taking a time complexity of big O of n log n. This is an inbuilt function, so it is taking a time complexity of big O of n log n. This for loop, this comparison, like this total loop is taking a time complexity of big O of n. So here we can also mention this big O of n. And to check for the space complexity, so basically we are creating a 2D vector array and storing the values. So it is taking a space complexity of big O of n. Okay, so if we sum up the time complexity big O of n log n plus big O of n, then it will be coming big O of n log n. Okay, and if we check the space complexity, then it will be big O of n. All points are cleared by this video, and if you liked it, then please do follow my channel and subscribe. Thank you so much for watching.